solve by substitution, or sometimes evaluate by substitution. You will be given an expression that has one or more variables in it, and each variable will be identified with a value. So here x is equal to 3, y is equal to -2, and b is equal to half. Our first expression has 3x plus 2 plus y. So we have three terms, 1, 2, and 3. We have two different operations. We have addition happening twice, and then multiplication, so the 3 times x. So now I'm just going to substitute in the values that I know to where the variables are. So we have 3 times x, and x is equal to 3, plus 2, plus y, and the value of y is -2. And you solve to BEDMAS. So now I have 9 plus 2 plus -2. 9 plus 2 is 11. 11 plus -2 is 9. The next one, same thing, 3. I'm going to replace 3 times b. I'm going to replace b with 1/2. And our original expression again had two terms, this time subtraction and multiplication. So 3 times 1/2 subtract y, and y is -2. And BEDMAS again. So using my multiplication, I know that that's technically 3 over 1. So 3 halves minus -2. Get common denominators. Is -4. And now I'm going to subtract. So keeping in mind my integer rules, 3 subtract -4 is equal to, I'm going to change the sign, add the opposite, so that's 7. So my new answer is 7 halves, which is 3 1/2. The last one. We have two operations happening. We have division and addition. So we have 1/2 plus 3 all over 1/2. So get common denominators. So we have 7 over 2 divided by 1/2. So now it looks more complicated than it needs to be. 7 halves divided by 1/2. So I'm just going to rewrite that as division. And then again using my multiplication rules, or division rules, we're going to multiply by the reciprocal, 14 over 2, and my answer is 7. And that is solving by substitution. Now, to take it to the next level, you could be substituting variables in for other variables. So here's, if you have x equals 3 plus y. So the value of x is everything that's happening here, depending on what y might be. So we could end up with, let's say, 3 plus x plus y, and we'll just say equal to 12. I'm not sure if it'll end up being a whole number, but that's fine. So I'm going to substitute in the variables that I know. So now I'm working with an equation and not an expression. We're going to do 3 plus, and I'm going to replace this whole amount, which is still unknown, but it's some quantity, and I'm going to substitute it in for x. So we have 3 plus y. It is important to keep the brackets here, so that when we are working with multiplication, like if there was a 3x here, we have to keep the brackets because of BEDMAS and the distribution property. And y, I don't know the value of y yet, so I'm going to leave it as y equals 12. Because there's no multiplication happening to this bracket, I can't do, if I'm looking at BEDMAS, I can't do anything inside of here. Brackets always comes first, and there's no operations that can take place because I don't know what y is, so I can't combine a 3 and a y. So now I have 3 plus y equals 12. 3 plus 3 is 6. Y plus y, well, we know we have two of them, so it's two groups of y. still don't know the value of it, equals 12. Now we have some balancing. I'm going to take 6 from both sides, and I have 2y. 12 minus 6 is 6. And again, some balancing, divide both sides by 2. And I have y equals 3. Now I can check it. Oops. So if I'm going to check this, I'm going to first find the value of x. We had x equals 3 plus y. So x equals 3 plus 3. X equals 6. So there's my first one. And now I'm going to substitute it in for the original equation. Always go back to the very beginning. And I'm going to have 3 plus 6 plus... Sorry, I just got distracted. These equal signs shouldn't be in the front because we already have an equal sign moving down the middle. Back to where we were. So we have 3 plus x plus 3 from this y that we solved for equals 12. And if this works, both sides should be balanced. Our left side should equal 12, and our right side already does. So 3 plus 6 is 9, plus another 3 is 12. So 12 equals 12. It's balanced.